Hello sir, my name is Mayank Raj, and in this video I'm going to walk you through OpenKB, which is an AI powered knowledge based application that I built from scratch. The core idea is simple. You upload any PDF document and you can then have a natural conversation with it using AI. No hallucinations, no guessing. The AI answers strictly from your document content. Let me walk you through the architecture, the code, and a live demo. So the project is built with the Next.js 15 using the app router, written in TypeScript and styled with Tailwind CSS and the SaaS UI. And for the AI pipeline, there are three key services working together. First is Google Gemini. I'm using two models of the Google Gemini. The first one is the Google Gemini embedding 001, the model which generates 768 dimensional vector embeddings from text chunks. And the second model is Google Gemini 2.5 Flash, which is the language model that actually answers users' questions. Both are accessed via the Google Generative AI SDK. The second is Pinecone. This is a serverless vector database. When a PDF is uploaded, its text chunks are converted to vectors and stored here. When a user asks a question, the question is also vectorized and we search Pinecone for the most semantically similar chunk. So the third is state management with Zoostan. I'm using two Zoostan stores, one backed by local storage to process uploaded document metadata across sessions, and one backed by session storage to process the chat history across page navigation within a single browser tab. So the overall all flow is a classical RAG pipeline, which is a retrieval-augmented generation pipeline. So the PDF, whenever you upload any PDF, what it does, it extracts the text from the PDF, it converts the text into text chunking, then embedding generation is done, upsert to Pinecone, then for a chat query, user question, embedded the question, query Pinecone, retrieve top matching chunks, and inject as a context into Gemini, and stream the answer back to the UI. So now I would like to walk you through the code. Let me start with the upload API. So this is a Next.js server-side route and API upload app. When a PDF is posted here, I firstly validate it's actually a PDF by checking the file name extension. Then I convert it into a unit8 array and pass it by page using the unPDF library, which is a serverless compatible PDF parser. It extracts all the raw text content from the file. So now, once I have the full text, I pass it into my chunk text function. This splits text into overlapping chunks of 1000 character with a 200 character overlap. The overlap is important. It ensures that context which spans a chunk boundary is not lost. For each chunk, I call get embeddings to generate 768 dimensional vectors using a Gemini embedding model. I then collect all these vectors and upsert them into a Pinecone in batches of 100. Each vector stores the doc ID, file name, and a raw text as metadata. So we can retrieve the original text later during the retrieval. So now the embedding library, which is the part B. Here's the embedding library. It uses the Google Generative AI SDK with the Google Gemini embedding 001 model, and the output is 768 dimensions. which is important because it matches the Pinecone index dimension. I also use a singleton pattern to avoid reinitializing the Gemini client on every request. So now I would like to show you the Rack Chat API. So now let's look at the chat API. This is where the Rack magic happens. The frontend sends the message history and the list of doc IDs the user has selected. I take the last user message, embedded it using the same Gemini embedding model, and the query Pinecone top K20 vector. I then filter those matches in application code to only include chunks belonging to the user's selected document. This is more reliable than using Pinecone's metadata filters directly. So now here is the key design, the zero hallucination system prompt. I instruct Gemini answer user's question only the document context provided below. If the answer is not in the context, say exactly I could not find the information in the uploaded documents. This grounding is what prevents the AI from making things up. So the response is streamed back using the Virtual AI SDK data stream format. So the answer appears word by word in the UI rather than waiting to the full response, much better user experience. So now I would like to show you the state management which I have used. For the state management, so I have created Zootstand stores, the user doc store, persist document, metadata, document ID, name, size, and timestamp to local storage. This means if you refresh the page, your document list will be still there. And the use chat store persists the chat conversation to session storage. This means navigating between the dashboard and the chat pages doesn't lose your conversation. But when you close the tab, that chat clears automatically. That's intentional. It's clear per session experience. So now I would like to show the live demo. Sir, this is the landing page for OpenKB, which is an AI assistant, document assistant. You can see the hero section with the gradient headline and the three feature cards below: vector storage, smart retrieval, and the instant answer. The entire app is in the dark mode with a clean premium design built with the sad scene UI and Tailwind CSS. So let me click start building free to go to the dashboard button. This is the dashboard. I can see my document library on the right side and the upload zone on the left. So there has already three PDFs are uploaded. Now I'll update one more PDF. So sir, here you can see there's an option to select or drag and drop the PDF. So I'll select to upload PDF. So let's select calendar management. Once I click and update, it will take 2-3 seconds to get uploaded. The PDF is uploaded, so behind the scene, the server is now extracting text, splitting it into overlapping chunks, generating a Gemini embedding vector for each chunk, and inserting those vectors into Pinecone. Sir, the document is now listed in my library and its vector are stored in the Pinecone. Notice the document is immediately selected and now I am going to the chat with it. So I'll click on the AI chat section. So here I already type hello and I have a question related to my document. Sir, on this screen you can ask any question like there's a PDF whose name is this. I'll type I have a related to this PDF. When I click enter, the AI will respond like, okay, please ask your question about the calendar document PDF. So sir, here you can ask anything about the PDF. So right now I'm not asking any question. So now let's see the document deletion process. If I no longer need a document, I can easily delete it from the dashboard. When I delete it, the app calls read endpoint, which uses the Pinecone delete main with a metadata filter to remove all vectors associated with that document's ID in the knowledge base stays clean. As you can see, sir, I clicked on the delete button and the document get erased. So let's talk about architecture summary now. So let me quickly summarize the architecture decision which I am proud of. One, first is fully serverless. There is no traditional database in this project. Document metadata is stored in the browser's local storage via Zootstand. The AI knowledge lies entirely in Pinecone. This means the app can be deployed to Vercel in minutes with zero backend infrastructure. The second is zero hallucination by design. The system prompt strictly prevents the AI from answering outside of the retrieval context. This is essential for any real world document QA use case. And the third is streaming responses. Using the Vercel's AI SDK's data stream protocol gives user instant progressive feedback rather than waiting for the full of AI response. And the fourth is the overlapping chunking. The 200 character overlap between chunks ensure no context is lost at chunk boundaries, a common failure point in a naive RAG implementation. So this is all about my project which you given to me. Thank you, sir.